India is known for its ambitious space program. From lunar probes to Mars orbiters, the Indian Space Research Organization, or ISRO, continues to reach for the stars. Now, ISRO is embarking on a groundbreaking mission, Aditya L1. This mission marks India's first dedicated attempt to study the Sun, our very own star. Aditya L1 promises to unlock crucial information about the Sun's behavior and its impact on Earth. Aditya, named after the Hindu sun god, represents India's aspiration to unravel the mysteries of our nearest star. This mission is not just about understanding a celestial object millions of miles away, it's about understanding how the Sun affects our planet, our technology, and our lives. The Aditya L1 mission is a testament to India's growing prowess in space exploration. It highlights ISRO's commitment to pushing the boundaries of scientific knowledge. This mission is a source of pride for India and a beacon of inspiration for the global scientific community. The Sun is a dynamic and complex object. Its behavior, though seemingly constant from our perspective, is far from it. Aditya L1 aims to study various aspects of the Sun to understand its intricate workings better. One of the mission's primary objectives is to study the solar corona. This outermost layer of the Sun's atmosphere is much hotter than the Sun's surface, a phenomenon that puzzles scientists. Aditya L1 will observe the corona to decipher the mechanisms behind this extreme heating. Another key objective is to analyze solar emissions. The Sun constantly emits streams of charged particles known as the solar wind. These particles can disrupt satellites, communication systems, and even power grids on Earth. Aditya L1 will study the solar wind to improve our ability to predict and mitigate its effects. The mission will also investigate the Sun's magnetic fields. These fields play a crucial role in solar flares and coronal mass ejections, powerful bursts of energy that can have significant impacts on Earth. By studying these magnetic fields, Aditya L1 will help us understand the processes that trigger these events. To achieve its ambitious objectives, Aditya L1 is equipped with a suite of 7 sophisticated scientific instruments. Each instrument is designed to observe and measure different aspects of the Sun, providing a comprehensive understanding of its behavior. The Visible Emission Line Coronagraph, or VLC, is one of the most crucial instruments on board. It will capture images of the solar corona, allowing scientists to study its structure, dynamics, and temperature variations. The Solar Ultraviolet Imaging Telescope, or SUIT, will capture high-resolution images of the Sun's photosphere and chromosphere, the layers below the corona. These images will provide insights into the processes that heat the corona and generate solar wind. The Aditya Solar Wind Particle Experiment, or ASPEX, will study the composition and properties of the solar wind. It will measure the speed, density, and temperature of the charged particles streaming from the Sun. The Plasma Analyzer Package for Aditya, or PAPA, will further analyze the solar wind, focusing on its interaction with Earth's magnetic field. This data will help scientists understand how the solar wind affects our planet's magnetosphere. The perfect vantage point. Why Lagrange Point 1? Aditya L1 will be placed in a halo orbit around Lagrange Point 1, situated about 1.5 million kilometers from Earth towards the Sun. This strategic location offers several advantages for solar observations. Lagrange points are unique positions in space where the gravitational forces of 2 large bodies, in this case the Sun and Earth, balance the centripetal force felt by a smaller object. This balance creates a stable point for spacecraft to maintain their position with minimal fuel consumption. L1 in particular provides an uninterrupted view of the Sun. Unlike Earth-orbiting satellites, Aditya L1 will not experience any eclipses or occultations, allowing for continuous observations. This uninterrupted view is crucial for studying dynamic solar phenomena like flares and coronal mass ejections. These events can occur suddenly and evolve rapidly. Continuous observation from L1 ensures that Aditya L1 won't miss any critical data. Journey to the Sun Aditya L1 mission timeline. The Aditya L1 mission is expected to follow a carefully planned timeline from launch to the commencement of scientific observations. Each stage is crucial for the mission's success and the eventual acquisition of valuable data. The mission will begin with the launch of the Aditya L1 spacecraft atop ISRO's Polar Satellite Launch Vehicle, or PSLV, from the Satish Dhawan Space Center in Sriharikota, India. Following launch, the spacecraft will undergo a series of orbit-raising maneuvers, gradually increasing its distance from Earth and spiraling towards L1. This phase is expected to take several months. Once Aditya L1 reaches the vicinity of L1, it will perform delicate maneuvers to enter its planned halo orbit. This orbit will allow the spacecraft to maintain a stable position while continuously observing the Sun. After the spacecraft stabilizes in its halo orbit, the scientific instruments will undergo a thorough checkout and calibration process. This phase ensures that all instruments are functioning correctly and are ready to collect scientific data. Earth and beyond. The impact of Aditya L1. The Aditya L1 mission promises to significantly impact our understanding of the Sun and its influence on Earth. The data collected by the spacecraft's instruments will be invaluable for various fields, from astrophysics to space weather forecasting. One of the key areas where Aditya L1's observations will be crucial is in understanding space weather. Space weather refers to the conditions in space that can affect Earth and its technological systems. Solar flares and coronal mass ejections are major drivers of space weather. These events can release vast amounts of energy and charged particles that can disrupt satellites, communication systems, and power grids on Earth. Aditya L1's continuous observations of the Sun will provide valuable data for predicting and mitigating the impacts of space weather. This data will help us better protect our technological infrastructure from these solar storms. Beyond space weather, Aditya L1's observations will contribute to a deeper understanding of fundamental solar physics. The mission will help us unravel the mysteries of the Sun's corona, its magnetic fields, and the processes that drive solar activity. A brighter future. Aditya L1's legacy. The Aditya L1 mission is a testament to India's growing prowess in space exploration and its commitment to advancing scientific knowledge. The mission's legacy, however, will extend far beyond its immediate scientific objectives. Aditya L1 is inspiring a new generation of scientists and engineers in India and around the world. The mission's success will encourage more young minds to pursue careers in STEM fields, ensuring a brighter future for scientific discovery. The mission's data will be shared with the global scientific community, fostering international collaboration in solar research. This collaboration is essential for tackling the complex challenges of understanding the Sun and its influence on Earth. Aditya L1 is paving the way for future solar missions, both in India and internationally. The knowledge gained from this mission will inform the design and objectives of future endeavors, pushing the boundaries of our understanding of the Sun and its place in the cosmos.